Hey everybody, Daniel here from Basement Tech. This video is going to be the first in a series of videos where I talk about the custom Python code that was written for the zimKnives monitoring project. What you see in front of you is the system diagram that I talked about a couple videos ago. Before I get there, I wanted to share something that I think is a little bit exciting, at least for me. I started a GitHub repository for not only the monitoring project, but for all of the work we're doing here in the Basement Tech makerspace. I'm going to post not just the software out there, but system diagrams like the one you were just looking at, schematic diagrams, the code, anything else that I think might be useful as references to these videos and the projects we're doing here in the basement. So back to the system diagram, just to remind you of what this Python piece of code does. As I said, it does two major functions. There are a few hardware bits locally connected to the Raspberry Pi, and the Python code reads those and makes them available to other parts of the system. The second thing it does is higher level alarming functions. If the system detects motion, perhaps it wants to, for example, send a text message or turn on a light. Those are the two major things that the Python code handles. In subsequent videos, I'll go into the actual code and talk through how I coded that to begin with. This video I want just to be mostly an introduction. Remember, I do have this data broker called Mosquito, which is kind of the center of the system. All of the data goes to the broker, and it then is redistributed out to various parts of the system which care. And then also I have a remote display / control piece of functionality that I'm using another package called Node-RED for that. So I do want to just show you the Node-RED dashboard so you kind of get an idea of what I'm talking about. Most simply, you know, the environmental parameters that are captured by the remote monitoring system are published to the data broker and then to Node-RED, and you get a display that looks like this. This is just simulated data, but this is the data that I've talked about in previous videos. I also might like to control things like manually turn on lights and manually turn on and off the automatic alarming functions, or just know what the status is. What is the system deciding to do via these little dashboard lights? So that's the kind of thing that I'm doing with Node-RED, and that's in parallel to the automatic functionality that this Python code might be providing. Lastly, I just wanted to talk in this video also about a few of my goals for the Python code and a few of the things I've discovered along the way. Remember, in subsequent videos I'll get into the actual code and talk a little bit more about things I learned about actual coding techniques. I wanted to use Python in a little bit more of a sophisticated way than just coding. Coding to me implies just banging out lines of software that perform a function versus actually stepping back, thinking about it, and doing what I would call software development or software design and development. Some people say software engineering. Personally, I reserve the word engineering for engineers, but actually giving some deep thought to a design for my software and then using the tool called Python to implement my design. Secondly, you know, and I'll say it now and I'll say it 1,000 times as I talk about Python, use classes. This is a goal of mine, as I said, to get more deeply into Python and produce something that's professional. And by that I mean sustainable, understandable, extensible. And those are the kind of things I took some time to do those things, both to learn the language more deeply, but also to end up with something that I can continue to build on, and I have. I actually just need to publish this thing because it's just so fascinating to keep working on it. Comments, you know, Python is largely a self-commenting software language, like so many, and if you use you know, appropriate and descriptive names for things, you kind of get the idea just by looking at the code what it's doing. But what I find myself doing with comments are two things. In cases where it's not completely clear, I want to spell that out, And then the last one is probably the most important for me, is leaving breadcrumbs along the way. So when I come back into the code, I can know what I was thinking when I coded something. So you'll see that throughout the way I'm doing the code. One other concept, a lot of the things, especially using the data broker, are event-driven in this code. There are a few polled things, but it's mostly event-driven, and that's a good thing. You'll see in the code. I don't have to do a lot of looping and polling and that kind of thing. Doing all of the above, taking advantage of object-oriented language means that when I get to the end, the actual while loop, which I'll show you first thing in the next video, it's very compact and very small because the classes and the way the code was designed is doing all of the work behind the scenes. So I want to end this here. It's just again meant to be the introduction, the -1, the video number 1 in a series of about 5 that are coming up. This is pretty exciting. I really like Python now that I've been using it for a while, and when I put that together in my skill set with C, I have kind of two languages aimed at a little bit different things that can really complement each other to build these projects that I'm talking about. I don't imagine too many people will thumbs up on this video because it's really a simple introduction, but if you do like it, definitely like it. And if you want to see this one, more like this one, and this whole series of videos about this Python code and finishing up other videos about this monitoring system in general, subscribe. So thanks for listening, and I look forward to telling you about the rest of the Python code.